part of the Pontifical Catholic University of Rio de Janeiro. And today I'll be presenting our study, which is called the construction of database interfaces based on large language models. So first, not working.
Yeah, it takes some time to start reacting.
Was working.
Let's try this one.
We try switching the issue.
Somehow it takes some time. Okay, I will. I will help you until it starts working.
Thank you. So first start with an introduction, so you can pass over this research topic and also some context around it. So typically the interface or the database requires SQL code, right? So whenever someone wants to retrieve a piece of information from a database, we need to provide the SQL instruction for that. And the problem with this approach is that this limits the usage for non-technical user, especially the one that are not familiar with the SQL language. So for that, we have the natural language database interfaces, please, which allows us to interact with this database by using natural language. By doing so, the interaction between the user and the database is similar to a human conversation. So the typical approaches for that have been based on keywords, patterns, parsing, and grammar. But our proposal is to take advantage of this recent developments in the field and base our solution in LLMs. And we're going to cover this topic in 3 different approaches. So the first one is what I'm calling here the interfaces based on GPT Prompt Engineering. In this case, we're going to consider the GPT LLM as it is. And we're going to use prompt engineering techniques to create this interface. So first, a quick overview of the GPT family. We have several models available from the OpenAI API. So we have the GPT base, which is not fine-tuned for dialogues. We have the GPT 3.5 Turbo, which is, then we have the 16K version of it, which allows us to use 16,000 tokens as prompts. And then also, of course, we have the GPT-4, which is the biggest and most expensive, and so on. And whenever we talk about LLMs in general, we need to have 3 key concepts in mind. The first of them is the prompts. So basically, the prompts are the input to the models. That can be both the description of a given task, but also some few examples of it. We also have the tokens, which are basically the result of breaking down the sentences in small parts. And these are the small parts are the ones that are actually processed by the models. And also, of course, we have the models itself. How it's working again. So, okay, so the easiest way to create a GPT-based database interface is to first create a description of the relational schema and feed that to the prompt. And by the time we have the natural language pair from the user, we also feed that to the prompt. And then we ask ChatGPT, given that the schema description and given the question given by the user, we ask it to provide the SQL query to the database. Right, so that's the easiest way. But this approach has certain limitations. The first is that we need to describe the schema in a way that ChatGPT is programmed to understand, which is natural language. That means you need to describe all the entities, all the properties, and all the relations of this database in natural language, which can be quite challenging depending on the complexity of these databases. Mm-hmm. The second limitation, of course, the database must have a schema, which is always true for relational databases, but not necessarily for RDFs, for example. And we have the token limitations, which in the case for ChatGPT 3.5 is 4,000 tokens, and this can also be a problem depending on the complexity of the database. Right, so another way, alternative way to create this interface is to use what we call the database keyword search tool. And the idea here is to, instead of asking ChatGPT to provide the SQL query straight to the database, we ask it to provide a list of keywords that is then fed to this keyword search tool. And the keyword search tool will provide the SQL query to the database. So the idea here is to remove some part of the complexity from ChatGPT to this search tool. And this search tool will take care of all the aggregation, all the joins, and all the filters that is needed to create the SQL query. And by doing so, then we are able to create less complex and also smaller prompts that is fed to the prompt. To evaluate these interfaces, one very popular way is to use the spider benchmark. Spider benchmark is a text-to-SQL data set that is manually annotated by 11 new students. That is composed of more than 10,000 questions, more than 5,000 SQL queries, 200 databases in a lot of different domains. And if you look at their leaderboard, basically all of them use some kind of variation from the approaches that I just showed. Some more complex variations, of course, but all of them use GPT-4 except for this last one, the C3, which uses GPT 3.5. Right, so now I'm going to talk about the second approach on this topic, which are the interfaces based on fine-tuning. So in this case, we're going to actually consider the update on the model's weights by fine-tuning it over our own data set. Well, first of all, a quick summary of the Llama family. The latest Llama family is the Llama 2 family, which is also an LLM similar to the GPT family, but is developed by Meta, and it has one fundamental difference from GPT, which is they are open source. So that means you actually have access to their weights, and we can fine-tune it in our own data. So Meta, they claim that they outperform other open source models, such as you can see on this table. And the models, they vary according to first the number of parameters. So we have the 7 billion option, the 13 billion, the 7 billion one, the biggest one. And also according to the use cases. And then also we have the base model, which is not fine-tuned for dialogues. We have the Llama chat, which is, and then we have Code Llama, which is pre-trained for code generation. Right, so the general approach for fine-tuning an LLM as a database interface is to first create a data set. Right, we have to create a data set based on pairs of questions and answers, and these answers are actually SQL queries from a specific database that we have in mind. Once we have this data set, we need to choose a model, which can be any of those ones I just mentioned. And then we fine-tune it over this data, and then we create a new chat model. Once we have this new chat model, we just need to feed the natural language query to it, and then the chat model will provide the SQL query to the database. So in this case, then we don't need to provide all the information of the relations or the entities and the properties in the prompt, because this was already fed to the model during the fine-tuning origin. So two limitations of this approach. First, of course, we need an annotated data set, which is always time-consuming and always expensive. And the second limitation is that the fine-tuning routines can be complex, especially depending on the complexity and the size of the data set. So one example, we have several examples of models fine-tuned from Llama. So we have the Alpaca model, which was developed by the Stanford Center for Research and Foundation Models. It is based on Llama 7B. And the interesting thing here is the data set creation, which they started with 175 manually written annotations. And then they used ChatGPT 3.5 to augment this data set by creating new instances based on this manually created. So by doing so, they ended up with 52,000 instances in one data set. And this is the data set that was used for evaluation. And for evaluation, for fine-tuning. For evaluation, they use the list of user-oriented instructions in several domains, and they claim that they reached the compelling results compared to GPT 3.5. We have several other models. We have GPT for All from Lchain. We have Dolly from Databricks. If you want to be updated on these models, we have this heavy face leaderboard, which is constantly being updated on a daily basis with these new models. All right, so I'm going to talk about the last topic, which is how to simplify the creations of these data interfaces by using generic LLM frameworks. So the first framework is Lchain. Lchain is a framework for the development of LLM applications, and it's composed of several components. So we have the prompt templates, which are basically pre-built templates for certain tasks. So if you want so you don't need to create a new template from scratch. For certain tasks, they're already provided. We have automatic connection to data sources, such as documents and databases and so on. We have agents, which are very specialized modules for certain tasks. And we can attach all these components together and build what they call a chain. Right, so there are a lot of use cases for Lchain. We have personal assistants, chatbots, Q&A for documents, and of course, query databases. Just going to show how simple it is to create one database interface by using the SQL database chain. So in this case, the only things we need to do is first call this the LLM, which in this case is GPT 3.5 Turbo. And then we call the SQL database chain method. We provide the database, the LLM itself, and that's it. So then we just need to provide natural language characters. We also have the Llama index, which is very similar to Lchain. It's basically an LLM framework for LLM development. And it's built around these three modules: the data ingestion, where we can connect to these data sources, such as APIs, PDFs, and documents. We have data indexing, where we can index these sources to our models, such as indexing documents, for example, in vector stores. And we also have the query interface, which allows us to make queries in natural language and also receive these answers in natural language. So in conclusion, we've approached the topic of constructing these natural language interfaces in three different approaches, right? The GPT Prompt Engineering, where we keep these LLMs as is and we use prompt engineering techniques. The Llama fine-tuning, where we actually fine-tune the LLM itself. And how to simplify the construction of these interfaces. So I think the main conclusion here is that there's a clear trade-off between the prompt engineering and the fine-tuning. While prompt engineering, the implementation is less complex, since we don't need one of the data set, we don't need to provide fine-tuning routine. But the prompts can be quite complex and quite long as well. It's going to be a real problem. And for fine-tuning, the fine-tuning routines can be complex, it can be very expensive and time-consuming to construct these data sets. But the prompt calls are very simple, since we don't need to provide any information that was already provided in the fine-tuning routine. And also one last conclusion over this topic is that this is a very, very hot topic, so things are changing every day. So it's very challenging to keep yourself updated, and most likely this presentation is outdated already. So, thank you.
Any questions from the audience?
Yes.
If you use the prompt engineering approach, your experience, how reliable and precise are the results that ChatGPT, for example, generates?
I think it's more reliable than the second option.
Okay.
Because you're grounding the information to ChatGPT, right? Once you use I think that's the biggest problem with the fine-tuning approach, because it's very hard to know where he's taking the answer from. Once you feed the exact prompt to it, I think it's more likely that you have the control over the answers. Basically, to be honest, basically all the latest and the best approaches have been based on that. Things are just beginning up, just starting. So I think there's a lot of other works related to fine tuning, which may look different.
So the output of the model is SQL code, right?
Yeah.
How do you handle errors that the model may do? Syntax errors.
There are a lot of options for that. One of them is to not read it. Then we consider that a mistake. But there are other approaches which are based on recovering itself from this error. So you can, for example, when you get an error, you can return that to the LLM and tell them that this generated an error. So fix it, basically. And a lot of solutions doing that. But the more you do that, the more expensive it gets, the more time consuming it is. So yeah, it's trade-off.
Always is talking about execution times. When how long does the user have to wait from the moment the natural language query is submitted to get the SQL call, for instance?
It's a very interesting question. We are testing. This is going to be another presentation, another word, but we are testing several options, and we are building this comparison between the models. And first, we started only comparing the accuracies, but at some point, we thought, you know what, we need to start measuring the time as well, because the differences are huge. So the answer is there is a big difference. It can be less than 1 second, and it can be more than 1 minute. So really varies a lot depending on the approach, depending on how many times you call it, if you want to recover from errors and on. So it's really useful.
By any chance, do you have any experience with the latest, like the GPT models in the field?
You mean the latest really late from last week?
No, not exactly, but maybe, yeah. So, or what do you expect
This moment.
from the example?
Yeah, that's the problem. We do have new models that were released last week, that's why I'm asking. Yeah, but we are, I think the best results we are getting is from GPT-4, for sure. But not that much as we expected compared to GPT 3.5. And one thing that we are also measuring besides the time is also the cost, because GPT-4 is, I think it's 1,000 or more expensive than GPT 3.5. So sometimes even if it is performs better, it isn't worth it.
I would have a question regarding security, because I assume you apply the public services for this experience, right? So if we have a private database, we should not use these public services answering the question from our proprietary database data, okay? Because we have, in this way we are basically publishing our data for other users. So what should I do if I have a proprietary data set and want to use these techniques?
This is also something we are facing as well, because we're researching that for an oil company, on which they cannot share the database with the public API. So our solution for that is that, well, they already have the internal endpoint for a ChatGPT API, which they separately agreed with Microsoft itself. So we don't actually have this problem because of that. But I think there are two ways to solve this problem in general. First of all is to use what OpenAI recently released, which is the OpenAI Enterprise plan, where they claim that they don't use the neural information to do anything. But also you can use open source models where you can run these models in your own infrastructure, which we are also doing with YAML, for example. Unfortunately, they're not that good as good as GPT, but this is also an option.
Okay. Thank you. If there are no questions, we can conclude this session, which was quite good and interesting. Thank you, everybody.
Your launch.